Good morning, grade 11 senior high school students of Cauayan City National High School. For today's video lesson, let's identify sampling distribution of sample means. To start, let's define sampling distribution of sample means and its steps in constructing the sampling distribution of the mean. The definition of sampling distribution of sample means is a frequency distribution using the means computed from all possible random samples of a specific size taken from a population. Steps in constructing the sampling distribution of the mean. Number 1. Determine the number of possible samples that can be drawn from the population using the formula as shown, where n is the size of the population, small n is the size of the sample. Number 2 step. List all possible samples and compute for the mean of each sample. Number 3. Construct a frequency distribution of the sample means obtained in step 2. Let's have an example. A population consists of 5 numbers 13, 14, 15, 16, and 17. Consider samples of size 2 that can be drawn from this population. Let's have the given. We have the number of your population, that is your capital N, that is equal to 5, and the number of samples, that is the small n, that is equal to 2. Let's determine first the number of samples using the formula of the combination NCN, that is equal to number of your population factorial all over number of samples factorial multiplied to the quantity of number of the population minus number of sample factorial. Let's substitute the given in the formula. We will have 5 combination of 2 that is equal to 5 factorial divided by 2 factorial multiplied to the quantity of 5 minus 2 factorial is equal to 5 multiplied to 4 multiplied to 3 multiplied to 2 multiplied to 1 divided by the quantity of 2 multiplied to 1 multiplied to the quantity of 3 multiplied to 2 multiplied to 1, that is equal to 120 all over 2 multiplied to 6, and that is equal to 10. So we have now 10 as the number of samples. Next, list all the possible samples and their corresponding mean. We have 2 columns in our table. We have the sample and the mean. Since we computed 10 combinations of our samples, we have 13 and 14, 13 and 15, 13 and 16, 13 and 17, 14 and 15, 14 and 16, 14 and 17, 15 and 16, 15 and 17, and 16 and 17. We will compute for the mean. We will add 13 and 14 for the first column and divided by 2, that is equal to 13.5. For the second column, we have 13 plus 15 divided by 2, that is 14.0. We have, for the third column, we have 13 plus 16 divided by 2, that is equal to 14.5, and as follows. For the third step, let us construct the sampling distribution of the sample means. We have 3 columns in our table. First is the sample mean, second frequency, and the probability. We have computed already from our previous slide our sample mean, that is 13.5, 14.0, 14.5, 15, 15.5, 16.0, and 16.5. Frequency of 13.5 is 1. For 14.0, that is 1 also. For 14.5, we have 2. For 15, we have 2. For 15.5, we have 2. For 16, we have 1. For 16.5, we have 1. A total of 10 frequency that is equal also to the number of our samples. For the probability of 13.5, we have 0.10. Also, 14.0 we have 0.10, 14.5 we have 0.20, for 15 we have 0.20, for 15.5 we have 0.20, 16.0 we have 0.10, For the 16.5, we have 0.10, a total of 1.00. That is our probability. Next topic is the mean and variance of the sampling distribution of the sample means. In this topic, you will be able to find the mean and variance of the sampling distribution of the sample means using formulas for the mean and variance of the probability distribution, and define the sampling distribution of the sample mean for the normal population when the variance is known and unknown. Let's have an example. Consider population with values of 2, 4, 6, 8, and 10. Number 1 question, what is the mean or the mu, variance, or the sigma squared, and the standard deviation or sigma of the population? To compute for the mean of the population can be computed using the formula mu is equal to summation of x divided by n, which is the number of the data. We have the solution. Mu is equal to summation of x all over the number of data, that is equal to 2 plus 4 plus 6 plus 8 plus 10 divided by 5, and that is equal to 30 divided by 5, which is equal to 6. Therefore, our mean is 6. For the variance of the population, it can be computed using the formula sigma squared is equal to summation of the quantity of x minus mu squared all over n. Here are the steps to compute the variance of the population. Step 1. Subtract the computed mean of the population from its value of x. Step 2. Square the results in step 1. Step 3. Add the results in step 2. Step 4. Divide the summation of the quantity of x minus mu squared by the value of n. Let's construct the table. We have the data, that is the first column, our x, that is 2, 4, 6, 8, and 10. For the step 1, we will subtract the computed mean of the population from its value of x. What is our mean? That is 6. So for 2, that is 2 minus 6 is equal to negative 4. For 4, that is 4 minus 6, that is equal to negative 2. For 6, that is 6 minus 6, that is equal to 0. For 8, that is 8 minus 6 is equal to 2. For 10, that is 10 minus 6 is equal to 4. For the step 2, we will square the results in step 1. For the first line, that is negative 2 squared, that is equal to 16. For the second line, that is negative 2 squared, that is equal to 4. For the third line, that is 0 squared, that is equal to 0. For the fourth line, that is 2 squared is equal to 4. And for the last line, that is 4 squared is equal to 16. For the step 3, we will add the results in step 2. That is 16 plus 4 plus 0 plus 4 plus 16, that is equal to 40. For the step 4, divide the summation of the quantity of x minus mu squared by the value of n. That is equal to 40 divided by 5, that is equal to 8. For the standard deviation of the population, it can be computed by simply getting the square root of the variance, that is sigma is equal to square root of sigma squared, that is equal to square root of 8, that is equal to 2.828. In this example, in our first question, what is the mean, variance, and standard deviation of the population? Our mean is equal to mu is equal to 6. Our variance, that is our sigma squared, that is equal to 8, and our sigma, which is our standard deviation, that is 2.828. We have the same example. For the second question, how many samples of the size 2 can be taken from the population? To find for the number of samples taken from the population, use the formula of the combination. That is, capital N combination of small n is equal to number of population factorial divided by number of sample factorial multiplied to the quantity of number of population minus number of samples factorial. We will now have our solution, that is 5 combination of 2, that is equal to 5 factorial divided by 2 factorial multiplied to the quantity of 5 minus 2 factorial, that is equal to 5 multiplied to 4 multiplied to 3 multiplied to 2 multiplied to 1 divided by the quantity of 2 multiplied to 1 multiplied to the quantity of 3 multiplied to 2 multiplied to 1, and that is equal to 120 all over 2 multiplied to 6, that is equal to 10. So we now have our 10 samples. Let us list all possible samples of size 2 from the population if the sampling is without replacement. Then calculate the mean of each sample. We have 2 columns in our table, that is our samples, the 2 and 4, 2 and 6, 2 and 8, 2 and 10, 4 and 6, 4 and 8, 4 and 10, 6 and 8, 6 and 10, and 8 and 10. To solve for the sample mean of each line, we will now have 2 plus 4 divided by 2, that is equal to 3, and then 2 plus 6 divided by 2, that is equal to 4, that is 2 plus 8 divided by 2, that is equal to 5, 2 plus 10 divided by 2, that is equal to 6, 4 plus 6 divided by 2, that is equal to 5, 4 plus 8 divided by 2, that is equal to 6, 4 plus 10 divided by 2 is equal to 7, 6 plus 8 divided by 2 is equal to 7, and then 6 plus 10 divided by 2 is equal to 8, 8 plus 10 divided by 2 is equal to 9. Now, let's construct the sampling distribution of the sample means for this population. We have 3 columns. We have the sample mean for the first column, our frequency, and our probability distribution. For sample mean, we have the 3, that is, for its frequency, that is 1, and its probability is 1 all over 10. Okay, for the second line, we have 4, its frequency is 1, and its probability distribution is 1 all over 10. For the third line, that is 5, that is, its frequency is 2 from our previous computation. So our population probability distribution is 2 all over 10 or 1 all over 5. For the fourth line, that is 6, its frequency is also 2. Its probability distribution is 2 all over 10 or 1/5. For the fifth line, that is 7, its frequency is also 2. Its probability is also 2 all over 10 or 1/5. For the sixth line, that is 8, and its frequency is 1, and its probability distribution is 1 all over 10. For the last line, that is 9, for its frequency is 1, and the probability distribution of 9 is 1 all over 10. The total frequency is equal to 10, which is equal to the number of our samples, and the probability distribution, when we sum it up, we will have 1. Okay? For the fifth question of the same problem, find the mean of the sampling distribution of the sample means, that is mu sub x bar. Compare this to the mean of the population. To find for the mean of the sampling distribution of the sample means, or the mu x bar sub x bar, we have steps to follow. We have step 1, multiply the sample mean, our x bar, to its corresponding probability distribution, that is P of x bar. Label this as x bar multiplied to P of x bar. And step 2, get the summation results in step 1. We have our x bar, that is 3, 4, 5, 6, 7, 8, and 9. And we have the probability, that is the P of x, that is 1/10, 1/10, 2/10, or 1/5, 2/10, or 1/5, 2/10, or 1/5, and 1/10 and 1/10. Okay, for the step 1, we will multiply the first two columns. Okay, so we have 3 multiplied to 1/10, that is 3/10. Okay, 4 multiplied to 1/10 is 4/10. 5 multiplied to 2/10, that is 10/10, or 1. We have 6 multiplied to 2/10, that is 12/10. We have 7 multiplied to 2/10, that is 14/10. 8 multiplied to 1/10 is 8/10. 9 multiplied to 1/10 is 9/10. We will sum it up. That is 3/10 plus 4/10 plus 10/10 plus 12/10 plus 14/10 plus 8/10 plus 9/10. That is equal to 60/10 or 6. Note that the formula in finding the mean of the sampling distribution of the sample means is the same with the mean of the probability distribution. We just replace the variable x with x bar, since the random variable in the sampling distribution of the sample means is the sample mean. So, the mean of the sampling distribution of the sample mean, which is our mu sub x bar, is equal to 6. The mean of the sampling distribution of the sample means is equal to the mean of the population. We can rewrite this as mu sub x bar is equal to mu. Let's have the sixth question in the same problem. Calculate the variance or the sigma squared sub x bar and the standard deviation, that is sigma sub x bar, of the sampling distribution of the sample means. Compare this to the variance and standard deviation of the population. To find for the variance, the sigma squared sub x bar of the sampling distribution of the sample means, consider the following steps. Step 1. Subtract the mean, the mu x bar sub x bar of the sampling distribution of the sample means from its sample mean x bar. It can be labeled as x bar minus mu sub x bar. Step 2. Square the difference of the population mean and its sample mean. It can be labeled as quantity of x bar minus mu sub x bar squared. Step 3. Multiply results in the step 2 by its corresponding probability. It can be labeled as quantity of x bar minus mu sub x bar squared multiplied to p of x bar. Step 4. Get the summation of the results in step 3. Let's have the step 1. Subtract the mean, which is the mu sub x bar of the sampling distribution of the sample means from its sample mean, that is x bar. It can be labeled as x bar minus mu sub x bar. We have our first column, that is our x bar, 3, 4, 5, 6, 7, 8, and 9. For our second column, that is our probability of x bar, that is 1/10, 1/10, 2/10, 2/10, 2/10, 1/10, and 1/10. For the third column, that is our x bar minus mu sub x bar, that is, since we computed our mu sub x bar, which is equal to 6, that is 3 minus 6 is equal to negative 3 for the first line. For the second line, 4 minus 6 is equal to negative 2. For third line, that is 5 minus 6, that is equal to negative 1. Then 6 minus 6, that is 0. Then 7 minus 6 is equal to 1. Then 8 minus 6 is equal to 2. And the last is 9 minus 6 is equal to 3. Step 2. Square the difference of the population mean and its sample mean. It can be labeled as quantity of x bar minus mu sub x bar squared. That is negative 3 squared, that is equal to 9. Negative 2 squared, that is equal to 4. Negative 1 squared is equal to 1. 0 squared is equal to 0. 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. For the third step, multiply the results in step 2 by its corresponding probability. It can be labeled as quantity of x bar minus mu sub x bar squared multiplied to probability of x bar. So we will now have 9 multiplied to 1/10, that is equal to 9/10. 4 multiplied to 1/10, that is equal to 4/10. 1 multiplied to 2/10, that is equal to 2/10. 0 multiplied to 2/10, that is equal to 0/10 or 0. 1 multiplied to 2/10, that is 2/10. 4 multiplied to 1/10, that is 4/10. 9 multiplied to 1/10, that is equal to 9/10. Step 3. Get the summation of results in step 3, that is 9/10 plus 410 plus 210 plus 010 plus 210 plus 410 plus 910, that is equal to 3010 or 3. So the variance of the sampling distribution of the sample means, or the sigma squared sub x bar, is equal to 3. Since the variance of the sampling distribution of the sample mean, sigma squared sub x bar, is 3, to find the standard deviation of the sampling distribution of the sample means, use the formula sigma is equal to square root of summation of the quantity of x bar minus mu sub x bar squared multiplied to p of x bar. That is, sigma is equal to square root of 3, which is equal to 1.732. So the standard deviation of the sampling distribution of the sample means is 1.732. The computed value of the variance of the standard deviation of the sampling distribution of the sample means is smaller than the variance and standard deviation of the population. As you observe, the mean, variance, and standard deviation of the sampling distribution of the sample means is as follows. That is mu, that is equal to 6, sigma squared sub x bar is equal to 3, and our sigma is equal to 1.732. Take note, as you observe, the computed value of the variance and standard deviation of the sampling distribution of the sample mean is smaller than the variance and standard deviation of the population. Next topic is the central limit theorem, definition, and illustration. Central limit theorem: if a random sample of size n is drawn from a population with mean mu sub x bar and variance of sigma squared sub x bar, and n is chosen large enough, then the sampling distribution of the sample mean x bar is appropriately normally distributed with mean summation of x bar is equal to mu sub x bar is equal to mu, and the variance, that is x bar, is equal to sigma squared x bar is equal to sigma squared x bar divided by n. This theorem says that regardless of the distribution of the population from which a sample is taken, we can choose a sufficiently large n so that the resulting sampling distribution will approach a normal distribution. In general, n that is greater than or equal to 30 is large enough for the sampling distribution of the mean to be approximately normal. We will now have a formula of z, that is z is equal to x bar minus mu divided by sigma divided by square root of n, where your x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, n is the sample size. Let's have an example. The average time it takes a group of students to finish a certain class activity is 39 minutes. The standard deviation is 8 minutes. Find the probability that 45 randomly selected students take the activity. The mean time it takes the group of students to complete the activity will be less than 41 minutes. I have here a table that shows the steps and solution. For the first step, identify the given information. That is your x bar, that is equal to 41, your mu, that is equal to 39, your sigma is equal to 8, and your n is 45. Second step, solve the problem. Let's use the formula of z to find the z-score. Z is equal to x minus mu divided by sigma divided by square root of n. Let's substitute the given in the formula. We now have 41 minus 39 divided by 8 divided by square root of 45, that is equal to 1.68. Now, locate the z-score in the z-table. Okay, I have here a table. Let's locate 1.6, and then 0.08. That is, the area now is 0.95352. The last step is state the answer. So the probability that the 45 students will complete the class activity in less than 41 minutes is 95.352%. That's all for the video lesson for this week. Thank you very much for listening and watching. If you have a question, queries, and clarification, don't hesitate to PM me in my messenger account or text me in my cellular number. Thank you. Bye.